All right, so you're going to be looking at how to solve square root equations. So up at the top there, they give us an example of one of these equations that has a square root in it. This one has already been solved for us to kind of tell us what we need to do to get the equation or solve the equation. It says the first thing we need to do is isolate the radical, which basically means make sure that there's nothing outside of your square root. That's all that first part means. Second thing is we need to square both sides, because the opposite of square root would be to square. So that's how we get rid of the square root, by squaring. After that, we simplify and solve, which is basically like the first equation we looked at on the board. It's just like any other equation, just solve for x. Of course, once you have that solution, you can always check your solution by taking the answer and substituting it back in and making sure that the left side and the right side are equal to each other. So let's take a look at some examples. Here's our first one. First thing we're going to do is isolate the radical, meaning we want to make sure there's nothing outside of the square root, which in this case we do have that situation. We have this side outside the square root. So we're going to start by moving that over here. So now what we're going to have is the square root of x minus 3 equals 9 minus 5, of course, is a 4. So I've taken care of the first step, which is to isolate the radical. The next step, step 2 here, says to square both sides. And the reason we're going to square both sides is because that's the opposite of square root. Opposite of square root is square. So I'm going to square this side, and I'm going to square this side over here. So when I square the square root of x minus 3, you're left with a x minus 3. When you square 4, you get a 16. So at this point, I have the equation x minus 3 equals 16. This is just like any other equation that we worked with in the past. So now we're going to do is simplify and solve that thing. So in this case, all I got to do to solve it is add 3. And 16 plus 3 is 19. So the solution to this equation is 19. Can I check it to make sure I got the right answer? Sure we can. We can always take that 19 and substitute it back in. So we're going to see just to make sure we have the right answer. So x is coming out, and I'm replacing it with the 19. And it should equal 9 when I get done. So let's see here. I know 19 minus 3. 19 minus 3 is a what? What's that? 16. And I know the square root of 16 is 4. And I know 5 plus 4 is 9. So notice how 9 is equal to 9. The left side is equal to the right side, so we know we're good. We know we have the right solution. So 19 is the solution to this equation here. Now let's look at the other one on the other side. This one's a little bit different. The first thing we got to do is just like the first one we did, we got to isolate the radical. So the first thing we're going to do is move the 3 to the right-hand side. So I've got the square root of x plus 5 equals what? What do you get when you add x plus 3? X plus 3. When you add an x and a 3, you get an x plus 3. Next thing is to square both sides. So the opposite of squaring is, or the square root is, square. We're going to square both sides. Now over here we know that the square root and the square cancel each other out, which is going to leave us with just the x plus 5. Here's where it's going to get a little tricky though. I need to square the x plus 3. So I'm going to have to come out to the side and do a little scratch work. I need to find out what x plus 3 times x plus 3 is. We're going to square it. Now when we square this or multiply it by itself, we're going to have to use FOIL method. So we're going to multiply x plus 3 times x plus 3. So here we go. This x times this x is x squared. This x times that 3 is 3x. This 3 times that x is 3x. And 3 times 3 is 9. All I'm doing is FOIL method. But we can simplify that. All right, so what can I do to simplify that? Add the x. And what do you get when you add the x's? 6x. All right, so we simplify it. And now we got x squared plus 6x plus 9. So that's what we end up with over here in our equation on the right-hand side. X squared plus 6x plus 9. And that's what I get after squaring both sides. Now we got a problem here, guys. Because this thing that I have right now is different from the first example that we worked together. How is this one different? What? Quadratic. This one turns out to be a quadratic. And how do we know it's quadratic? Because it's got an x squared in it. So let's think back to last semester. When you're working with a quadratic, how many solutions am I going to have when you work with a quadratic? 2. How do we come up with those 2 solutions? Got a couple of different methods. Factoring is one. Graphing and quadratic forming. Those are the 3 methods that we've looked at in here. So the question is, which is the easier of those 3 methods to use? I don't know, it depends on you. For me personally, I think graphing is the easiest. It's fast, easy, and there's very little work that I have to do myself. So that's the method I'm going to go with. Now, it doesn't work all the time, but if I can try that one first and be successful, that's what I'm going to go with. By the way, before you can use any of those 3 methods, what does it have to equal first? 0. So let's make sure we get this thing equal to 0 first. So let me move some things around. I'm going to move the x and the 5 over to the other side. So what I'm going to do is take 6x's and subtract the other x, which is going to make us have a 5x. I have 9 over here. I'm going to take away 5, which is going to leave me with a 4. So now I have the equation 0 equals x squared plus 5x plus 4. So now I can go ahead and use either graphing, factoring, or quadratic formula. But like I said, let's go ahead and do the graphing method first because it's the easiest of all 3 methods. All right, so let's graph it. And what we're going to be looking for are the x-intercepts. Those x-intercepts represent our solutions. Let's see what those x-intercepts are. How do we graph that? All we do is go to y equals, type in x squared plus 5x plus 4, hit graph, and find your x-intercepts. And I think we do have 2 x-intercepts that work out nicely, right? And what are those 2 x-intercepts? -4 and -1. So I'll agree, -4, -1 is our solution. All right, so this particular equation, we have 2 solutions, -4 and -1. Can we check this to make sure we have the right answers? Sure we can. We can take these 2 numbers, plug them into the equation, and make sure that the left side equals the right side. So that's what we're going to do, just to make sure. Make sure there's no funny business going on. So I'm going to start with this -4 here. Just checking it, making sure I'm okay. All right, so here it is. All I did was take out the x's and replace it with a -4. Let's see what's going to happen. Right here, -4 plus 5. -4 plus 5 is a what? -4 plus 5 is 1. The square root of 1 is 1. And 1 minus 3 is -2. Wait a minute, did we make a mistake? Did anybody see anything wrong? Let's see. I put in a -4 for the x's. Let's check the math here. -4 plus 5 is 1. We took the square root of 1, which is 1. And 1 minus 3 is -2, not 4. So what the heck's going on? Did we make a mistake? Hello? Lindsay, help us out. Why is it not working? Did we make a mistake up here in our quadratic? You sure these are -4, -1 for your x-intercepts? Y'all double check that again. You sure it's -4, -1? Huh? This right here does not work out, guys. The left side of the equation is not equal to the right side. So even though we found our solution with quadratic or with the graphing method, this -4 that we found is not working for us. So we can't include it as part of our solution. We got to get rid of it. That's something called an extraneous solution. It's a solution, but when you plug it in, it doesn't work. So we got to get rid of it. We're not going to include that as part of our solution. Now, we better double check this -1, because it may also be one of those extraneous solutions. It may not work either, so let's double check it. So we got -1 plus 5 minus 3 equals -1. -1 plus 5. -1 plus 5 is a 4. The square root of 4 is 2. And 2 minus 3 is a -1. Now, -1 is equal to -1, so we're good here. So, in this particular case, even though we had a quadratic and we found the two solutions, only one of those solutions actually works when you plug it back in. So, this right here is the only solution, -1. We cannot include the -4. And if you actually put that -4 on a test or on your homework assignment, I would count it wrong. So, make sure you only have the -1. So we need to be very, very careful about checking our solutions, guys, especially when it comes to quadratics. Always double check your work. Okay? All right, let's keep going here. Well, then if both of them work, good question. Let's say that this -4 did work out where the left side was equal to the right side. Well, then we include both answers. We would say, oh, both of them didn't work out? All right, then we would say that there is no solution. And that might happen as well. Doesn't happen too often, but you never know. You might see that. No solution. All right, so let's go to the bottom of the page and let's look at A. A, we want to solve for x. Notice there's a couple of things hanging outside of the square root, so we're going to have to take care of that problem first. The first thing I'm going to do is move this 3 over. So let's see, 15 minus 3. 15 minus 3 is 12. But I still have something outside the square root. So I want to get rid of that 2, because I cannot have anything outside the square roots before I square. So let me divide by 2 now. So 12 divided by 2 is 6. So notice at this point, there's nothing outside the square root. We have just isolated the radical. So the next step we have to do is square both sides, because that's what's going to get rid of the square root. Square it. We're going to come over here and square both sides. When I square this side over here, we're going to end up with x plus 7. When I square the 6, I end up with a 36. So notice there's no more square root in the problem. Now it's just like any other equation. So now I can finish it up by subtracting 7. And 36 minus 7 is a, what? 36, 29. So the solution here is 29. Now your assignment today is not a very long assignment, so I do want you to go ahead and check your solutions to make sure you didn't make any mistakes. So we're going to check that right over here. Okay? And you may have to do it on the back or on a separate sheet of paper if you don't have enough room. So all I'm going to do is check. All I'm going to do is replace x with a 29. Yes, we can also do that. If you're too lazy and don't want to show all your work, in this case, we can take all of this right here. Put that in the calculator, but be very, very careful when you're typing it in, though. Make sure your plus 3 is on the outside of the square root. All right, otherwise you're going to think it's the wrong answer. So we're going to do 2 square root of 29 plus 7 plus 3. We're checking to see if we get a 15. If we get a 15, we're cool. If we don't get a 15, we got a problem. So when you type that in, do you get a 15? Yes, then we're okay. This 29 is the solution. So yeah, you can go ahead and use your calculator to check your answers. All right, let's check the next one here. B, we got x is equal to the square root of x plus 20. Notice there's nothing outside of our square root, so we're okay on that first step. It's already isolated, which means I can move on to the next step, and that next step is to square both sides. That's what we're going to do next, square both sides. So if I square the x, that gives me an x squared. If I square this side over here, I get an x plus what? So notice, like one of these examples that we looked at, this ends up being a quadratic. And I know it's a quadratic because of the x squared here. The method I like to use on quadratics is the graphing method. It's just faster and easier. But before I can use that method, I want to make sure I get this thing equal to 0 first. So let me move some things over so that the equation is equal to 0. So I move the x and the 20 by subtraction. Now we're ready to go. So now we can either graph that, factor it, or use quadratic formula. Again, I prefer graphing. It's just faster and easier. It is a quadratic, so we are going to get two solutions. The question is, what are those two solutions? Negative what? Negative 4 and positive 5. So I'm saying my solutions are negative 4 and positive 5 by looking at the x-intercepts. However, we saw earlier when we had a quadratic, one of them didn't work out. So we better double check on this one. Let's try both of these. Let me start with a negative 4. Alright, so let's see here. Negative 4 plus 20. Negative 4 plus 20 is 16, and the square root of 16 is 4. Is a negative 4 the same thing as a positive 4? No, they're not the same thing. So this negative 4 that we had, not going to work. So don't include it as one of your solutions. Doesn't work. Better go ahead and check the other one. You never know. So let's do 5 equals 5 plus 20. 5 plus 20 is 25, and the square root of 25 is 5. So it looks like we're okay on this one. So our solution to B is just the 5, not the negative 4. There's only one solution. Alright, let's do one more here. C. C, we got to get that square root by itself. We got to isolate it. So the first thing we're going to do is move that 10. So now we got the square root of 4x minus 3 is equal to a negative 3 plus 10. A negative 3 plus 10 gives us a 7. Since I've got my square root isolated, now we can go ahead and square both sides to get rid of it. So if I square the left-hand side, that leaves me with 4x minus 3. If I square the 7, that gives me a 49. And all we got to do now is solve it, just like we were linear the equation. So we'll add 3. 49 plus 3 is a 52. Divide that by 4. And 52 divided by 4 turns out to be what? 13. So right now I'm saying my answer is 13. However, you never know. We'll come over here and check our work. Let's go ahead and replace that x with a 13. And like I said, you can use your calculator. Just make sure you type it in correctly. Make sure the minus 10 is on the outside of the square root. And let's just make sure we do in fact get a negative 3. Do we get a negative 3? Yes. Alright, so then our answer that we came up with is good. We're okay. Alright, so this is how we solve equations that have square roots in it. Just remember, opposite of square root is square. Alright, over on the back page there,